cover, and the door hits that. But guys, look at the schematic of those three switches. We got one here, and one here. Can you identify which one is totally different? And I'm not talking about by the way it's drawn, but which one is different than the others and why?
Low voltage and high voltage?
Yes. These two switches are 5 volts DC, where this one is connected directly to the auger motor, and this is the neutral line, so therefore these components are 120 volts, and this switch is running off of a 120 volt circuit. Remember the other class, and if you missed it, it's posted online. This board was divided in half, where everything on this side is DC voltage and everything on this side is AC voltage. So if I wanted to check a component from the board, can I really check this auger motor or this cube crush solenoid from the board?
Yeah.
So let's see if I got a more complete diagram here. And I don't see a full diagram here that I could show you. Might have to go somewhere else to find that. So I'll go back to that question if we have time. But how would I check this auger motor here? This one might help.
Could it be K3, pin 1 and 2?
Well, you and I talked about that in class, and the problem is if you don't get a reading from that pin location, so if I go here and here with my meter lead on the board, then I'd be checking what? I'd be checking through the door switch, through the auger motor, and the crush cube solenoid come back. Now if the door switch is bad, the auger switch is bad, you're going to get a reading?
Yeah.
If the switch is bad?
No.
No. What if the auger motor's bad? I won't get a reading. If the solenoid bad, I won't get a reading. There's too many parts in there to ohm out that circuit to identify which one of them is the fault. So if you had an auger motor that wasn't working and you says, well, let me look and check continuity here. Well, that really isn't the best place to go. But we could reduce that. Anybody get any idea how I could reduce it?
I was thinking of doing a voltage test.
Okay, so where would you do your voltage test? That's a good test.
So if I do a voltage test on J3,
Okay.
and I can isolate the board. I know it's not a board, then it has to be any of the components on that path.
Okay, so let me ask you a question. Where are you going to put your meter leads to make that test? There's enough information in this image to answer that question.
Oh, for the board?
Uh-huh.
I wonder which of 1 and 2 is the line.
Okay, well, I will give you that much. 1 and 2 are both line. They're both line 1.
Line, then.
Well, remember, pin 1 is feeding line 1 into the auger motor, and pin 2 is feeding line 1 into the crush cube solenoid, so we could turn them on separately. I could run the motor without, turning on the cube solenoid, or I could run both. But light blue, as we discussed in a previous video, is neutral. So if you wanted to check it, I'd check here, voltage coming out, but where am I going to put my other meter lead?
It's neutral.
Is it neutral?
Where would that be?
In 9 on top?
Number 9 on top would be the neutral. So I could use that. It's light blue also. Now, in the diagram, they connect together. This is the light blue, and it comes up here, and this one goes up there. So I could do that voltage test there from the board. So this plug, I don't know the plug number, but this is J31. So let's go back to our image here, where J31, I'd have 1 meter lead here, and the other one was neutral above it, but obviously I can't see that from this board image. I need to see the whole diagram. So I'm gonna go here and see if I can find that neutral on the board here. So here's the neutral. That would be J39. So guess what? They're on the same plug, aren't they? This is J3 and this is J3. They drew it. There's not two separate plugs there. It's all the same plug. The drawing, it looks like they're two different plugs on your board. It's just a different location. It's controlling different parts. But look, this is 1, 2. There's a space here. That doesn't mean there's a space on the original plug. And then this is 3, 5, 6, 9. And we may have some more J3s above. I don't know. But J39 would be the same plug. So let's go back to where we were doing that test. So this is 1. I go 2, 3, 4, 5, 6, 7, 8. There's nothing there. 9 would be that one. Your meter lead would be here. They're all on the same plug. In the drawing, it looks like they're two separate plugs, but they are the same plug, and that's how we read it. J3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so if I was to carry that over to this real board, can someone give me an idea where am I on this board? I'll like hover here. You tell me go up, down, left, right. I'll stay right here.
To the left.
To the left? How far?
Yeah, this one.
Down.
Okay, now I'm going to go here to J3 pin 1, and I'm going to go here to J39. So this is that same test. That is where you're physically putting your meter to do that voltage test that we just said. Now if I had voltage and my auger motor, the ice bucket motor, is not running, does that give me enough information to determine what is wrong? So what more do we need to do to prove what is the fault? Because if I have voltage here, that means what?
Board is good.
That the board is good. And these little white boxes are the relays. So let's just say, for example, this one here is 9, or this one here is whatever number, it's 6, 9, 8, whatever. I don't know what number does which part. But if you really want to know which one of these relays was going to pin 1 and 9, is if you flip the board over, you can follow the traces on the board and see which one goes here and here to power that power. But if I have 120 there, I still have to do what to determine my fault in this circuit? Having 100, I'm sorry?
Resistance check.
I can't do a resistance check because, I'm sorry, I'm trying to go to that screen we were just on. Where was I? I must have been here. So if I do a resistance check, even if I do 1 to 9, I still have 2 parts. So I either have to check the switch or I have to go to the motor. I would prefer to go to the motor and do a voltage test at the motor. I know it's going to take a little bit. You got to take the ice bucket out. You got to take the cover and everything off. It's French door and everything. But if I go to the motor and I have voltage, I know my motor's my problem. If I don't have the voltage, what would you do?
Check somewhere else.
Well, most likely it's this switch right here. Because before we said, oh, 9 and 1 here on the board, this is where we're testing, and I got voltage at this point. Now I go to my motor here and I check for voltage on the motor, and I don't have it. Well, from here I had it, but I don't have it here. Most likely my auger switch might be my fault, which most likely you might not even have that in your truck and you have to order it anyways. But if you took the switch out to test the switch first and the switch ohmed out good, you're still going to have to go to the motor because you don't know if a wire's bad or whatever. And those auger motors are an electric motor with a gearbox before it rotates, and it uses that gearbox so it doesn't stall the motor and can crush these cubes. But I've seen a lot of those gears like freeze up it's almost like they get moisture in there, and one of the teeth of the gears have ice on it, and so you can hear the motor hum, but it won't rotate. I've sat there with a heat gun and just pulled the bucket out right on the two little forks back there and just sat there for a few minutes with the heat gun, and all of a sudden the motor ran. I melted the ice holding that thing together. So this is the auger motor, but you want to make sure if you have voltage coming off the board, you want to make sure you got voltage coming to here, because we have a connector here, we have a connector here, we can have a connector problem. You know, it could be any of these things. So checking voltage directly to the load is going to tell you if the load's bad or the circuit's bad. Okay? So this is the ice maker and thermistors in the box. They're all low voltage. There's only one part that's not 5 volts in that circuit, and what would that be? You guys want me to make it bigger for you? I'll bring it to the front. Hold on. What part is not 5 volts on this?
The tube heater?
The fill tube heater. And why has it got dotted lines? It's not drawn like everything else. Dotted line means that the machine may or may not have a fill tube heater. If it had it, that's where it would be connected in the machine. If it don't got it, don't get upset. It's just don't have the part. So the dotted lines in this circuit here mean if the refrigerator came with one from the factory, this is how they would wire it, and this is where you would test it. But if you don't see it, don't worry about it. There is one other 12 volt here. Do you know what that is? You can't see the part, but what do you think it is? The P.
Signal voltage.
What is PWM?
All
switch modulator.
Okay, and that's usually your evap or condenser fan motor, and I see an FZ1 right there, so it's probably the freezer fan motor here. So that's what that is. Look at this one twist motor. This is the auger motor that we were just talking about. No, actually, that's not the auger motor. What is that? The twist motor.
The one that right?
That ejects the ice.
The ice motor. I'm sorry, Ali, I didn't hear you. You cut in and out. But that is the one that twists the flex tray on the ice, and it says reversible. So what do you think that means? What's actually happening to make it reversible? They're changing.
Polarity?
Yes, they're changing the positive and negative on pin 2 and 3. So the ice motor starts running, and let's just say 2 is positive and 3 is negative. And then as it continues to rotate and gets to the end, it stops. And then it'll reverse, so then 2 and 3 now switches the plus and minus for that to be reversed. Now the bail arm switch, what is that? That's the arm on the ice maker that tells the ice maker the bucket's full and to stop making ice. So I'll show you a picture of it in the next screen, but that's what that is. And where would I find the ice tray thermistor?
Could be in the bottom.
Underneath the plastic tray. That's the one that's always attached to it, and then I don't know if you guys probably seen them where the bracket that holds them, and then the thermistor's hanging down inside the ice bucket. At that point, you just got to change the ice maker altogether. Oh, I wanted to go over these thermistors here. So we have three thermistors. What is the function of the 3 thermistors? Let's start off with the freezer thermistor. What is the function of that? The purpose of it?
To make temperature in the freezer.
Yes, this is how the refrigerator knows the temperature in the freezer. That would be plug J6, pin 7 and 8. So if I look here, J6 is this plug here. Notice the configuration 1, 2. So all the pins on the left hand side here are odd, and all the ones on the right hand are even. And we're going to 7 and 8. So I'd go 1, 3, 5, 7, and 8 would be right there. And then I didn't have my meter leads on this screen. I would be on this plug over here. Let me get my meter leads from this screen and bring them over here. I had to make these images for the class. Oh, they were here. I didn't even know it. So 7 and 8. Now we don't know which is plus and minus on here. They don't specify by colors or whatever. So 7 and 8 would be 1, 3, 5, 7. So 8 would be here, and 7 would be there. So that's where your meter lead would be. And this especially be one of the ones where you need those thin meter leads, because if we wanted to check the 5 volts coming off this board, we'd have to plug it in, and then we'd have to go in through the plug, and these meter leads are just way too big to fit in there. Now I can also ohm out the thermistor. What is the freezer evap thermistor for?
The defrost thermistor.
That's correct. We were talking about that on the other diagram. That's the one that's telling the refrigerator the evaporator temperature, not the freezer temperature. And that's the one that's controlling how long the defrost heater stays on in a defrost cycle. What is the function of the fresh food thermistor? How does it work?
Did it tell the temperature from the bottom tray with the food?
Not it tells the temperature of the refrigerator, yes, but what is it telling the board to do? Is it going to tell it to turn the compressor off when the fridge is cold? It is to control the damper for the air flowing from the freezer into the refrigerator. Hold on one second. I want to see if I can open up that that document, that wiring diagram again. One second, guys. I thought I had the full diagram in the screen here, and I didn't. Oh, it tells me I can no longer open that file. Why? I don't know. Sorry about that. Well, I'll see if I can find it in another screen here. But there is a damper in this unit, and that damper is being controlled by that unit. Here we go. See if I can find the damper on here. I haven't even looked for it. Here it is right here. Our damper's right here on our plug J5. I know it's a little blurry, but I can't screen capture it and get it. Well, that's why I have to do it little pieces. But so that fresh food thermistor is telling the board, hey, the refrigerator's too cold, and then the damper will close and restrict the air from the freezer to cool the fridge, or otherwise it's going to freeze your milks and stuff. I had a guy, he called me out, a friend of mine, and I was saying his freezer wasn't cold enough. No, his fridge wasn't cold enough, and it was a side-by-side just like this one here, and it was a Frigidaire as a matter of fact, but the damper's located up top inside the refrigerator, and he had a little tiny a cream, like a coffee creamer container that was rectangular and tall, like the one, not like the 1 quart milk jugs, not the jug, but the square plastic containers, whatever. And it was blocking the airflow into the fridge, and it was freezing the creamer. So what happened was, even though the damper was trying to open and close, they were obstructing the air. Whirlpool, they have a damper up top here, which is just a little window allowing the air from the freezer to come in. You have to have a place for the return air. Now most refrigerators, if you remove the lower bin here, there's an opening in the wall where the air can go back in the freezer so that we can have a complete circulation. Whirlpool has these two bins on their side-by-sides, and for years they had a vent right on the side wall, and it goes through the wall and goes down into the freezer through here, and people would put like a loaf of bread or something, and that would block the return air, so the freezer would be cooling just fine, but the damper's doing its thing. But if you block the return, nothing's going to come in on what we call the supply. So that is something you have to watch for. And another thing on the Whirlpools is that if the flap in here doesn't close all the way, warm air humidity gets in, goes to the damper, and then comes back here, and I've seen inside the channel in this wall freezes solid with ice. So you go there and there's nothing blocking it, but the humidity that was coming in through this door flap was causing freezing on the return air. So that's something you guys need to look out for. Now let's go to okay, we did those thermistors. So we have 3 main thermistors in this unit. Some refrigerators have a lot more, like ambient thermistors and stuff. We're not going to get into that yet. So here is the ice tray. That's the bail arm right there that I was telling you about. And through diagnostics, you can go in and test the bail arm in one step, and you lift it up with your hand up and down, and that will tell whether the bail arm is working. But what kind of complaint would happen if the bail arm is defective? Basically, I have 2 complaints.
It would make too much ice.
Too much ice, or not make any ice at all. If that switch is defective, the ice maker won't work, right? So our thermistor is encased in this styrofoam right here, and those all the time come apart because you're flexing this tray, and you're putting a lot of stress on where it's glued in or where it's mounted, and usually when they fall out, you're just going to go ahead and replace the whole ice maker. So you got bail arm, tray, and then inside of here, what's inside this box?
Switch.
With motor?
It's just got a motor and a switch. Does it have a circuit board in there so the ice maker, would run?
No, I think switch, right?
It's just switching the motor. The main board is what's controlling the ice maker. So this ice maker doesn't have a board in it. So the sensor and the motor, they're all going back to the main board, and the main board is what's cycling the ice maker. So if you go to this unit and it's not making ice, what's one of the first things you look for? Customer calls you out and says, hey, my ice maker's not making ice. So you're like, okay. You go in there and you see it's cooling and stuff. So what's the first thing you want to look for? Ice in the tray. I know it's upside down, but first thing to do is, like, if the customer says there's no ice and you pull the bucket out, there's no ice in the bucket, you want to look in the ice tray of the ice maker and see if it has ice and it's not dropping. If it has no ice in there, what kind of problem would you be having?
Water problem?
A water problem, a water valve problem. Very good, Bobby. So that could be like no water coming in, filter could be clogged or whatever. Yes, the board may not send power to the water valve, but that way we could test through diagnostics. You go to diagnostics and now water comes in, but it didn't come in on its own, then it's the ice maker itself. Maybe the bail arm switch is bad, thermistor's bad, and it just doesn't know to cycle. So they're very simple to troubleshoot. And the diagnostics, you check the arm, see if the motor twists, and see if water comes in. Those are the only 3 things you could do. So this is all controlled by the main board. Any questions on that?
Yeah, I got a question, Richard.
Sure.
These pins right here where it says IM2, IM1, and it's like a whole, like, pin 2, pin 1 on the twist motor, the bail arm switch, and the tray thermistor. You see those two? Are those relays separately?
They're not relays. You see what I circled there?
Yes, correct.
That IM2 is this plug. IM1 is what plugs into it and goes back to the board.
Oh, okay.
All that is a quick disconnect.
So we couldn't do tests from these IM2 and IM1.
What kind of test would you do? Yes, you can. Give me an example. Give me an example of a test you would make. I'm sorry to cut you off.
Yeah, like if you just want to test the twist motor to see if it was working or not, could you not test it from the IM2 pin 1?
Yeah, so we can look for ohms
Yes.
or voltage. Which one would you do?
I think it would be voltage.
I would be voltage. Again, I like to use voltage as a test point. I'm just going to use 2 black meters because I only copied one by mistake. So I would go into the plug here and here, which would be pin 1 and 2. So basically, you're going right inside this plug here. But we want to leave it connected, so we're going to go on the back side with our skinnier leads. And what are you going to do? You're going to do what in order to make this test, and what are we looking for?
You would actually be looking for voltage, right? But it would have to be engaged. So
Well, how much voltage?
12, 5 DC.
12, right here, reversible 12.
Right.
Okay, so that motor is running off of 12 volts. If I had 12 volts right there, what would you do if the ice maker didn't move?
Test the twist motor.
Change it.
Okay.
I mean, if I have 12 volts where my 2 black meter leads are here, I'm checking like right here, and I got 12 volts and that thing ain't moving. I'm done. The motor ain't working. It may not be an electrical problem. The motor has gears. The motor is probably very similar to like a turntable motor on a microwave or something, a little geared motor. And the motor can be good electrically, but the gears could be bad. So if you have 12 volts here and this thing doesn't move, that's it. I'm done. Ma'am, I got a new ice maker. I'm going to slap it in. You'll be good to go. But like you said also, we're going to have to go into the diagnostics and tell that board, hey, apply voltage there. I want to see the twist motor. So there's a couple of tests through diagnostics you can make, and one of them be to fill with water, the other one would be the bail arm switch, and the other one would be the twist motor. So you're going to apply voltage to the twist motor by doing that, and then you could check so you got voltage there. If you have voltage, the ice maker's bad. If you don't, the board's bad.
Okay.
Unless it's got a wire broke in the cabinet, which very rarely happens. But this doesn't have a lot of serviceable parts.
Okay.
Now I want to get to this circuit. A lot of people aren't aware of this. If I want water, I put my cup here. I got a cup. If I put a cup in the refrigerator to get water, what is energized?
Is it the
Dispenser valve?
Okay, is that the only valve?
The main inlet valve?
That's correct. Why 2 valves?
Because you need water inside.
A little bit more than that. Anybody else got any idea why 2 valves?
Because as you take water from the reservoir, the main inlet valve fills the tank back up from the water that you took out.
Yeah, but these 2 valves are what we call in series. Water has to flow through the inlet valve and the dispenser valve before it comes to the door. And what's happening, let me see if my drawing is good with a computer. It's here's your refrigerator and your water valve's down here in the back. So the water comes into the valve to the main inlet first. So when we look at it, there's 3 solenoids on here. Let me just get a water valve. Sorry. I got it right here. Let me just copy this image and then post it over here. 1 second. Oh. Copy image and paste. Okay, so this is the water valve on that refrigerator. Okay, we got 1, 2, 3 solenoids. 1, 2, 3 solenoids. The first water valve here on the right, water comes in at the very top here to this piece. And then when a customer is calling for water, it comes out this valve. So it comes out the valve and it runs all the way up to what? What's located in the upper right hand corner of most refrigerators?
Filter.
Your water filter. Whether you're calling for ice or water, it's going up to that filter. Then the filter is going to come back, the water is going to come back down the filter to the valve. So this one is then going to come back to here. So there's a filter here in the middle. Okay? So it filters whether you're drinking water or making ice, it goes through the filter. Now, depending on which one of these two here we energize, there's one here, you can barely see it. It'll come out here and here. Now there's two openings. I'm going to make this bigger because I want you guys to look at it. I'm going to ask you a question about them. Let me clear this. Okay, so here's the water valve. I'm going to repeat it. Water comes in here, goes here to the filter. I'm just going to put an F here. Filter. And comes back here. We have two holes there. Which one of those two is the ice maker and which one of those two is the water on the door?
The smaller diameter one is for the ice maker.
Wow, you got a lot of, you're very good. You got a lot of knowledge. You've been doing this for a little while, haven't you? So yes, this one here, the smaller one is for the ice maker, always. And the larger one is for the water on the door. Okay? Just so you guys know, 5/16 1/4 inch. Those are the only two lines you need. And you can always get some of them from Home Depot or something. It's always good to have a little bit of line on your truck, especially on some of these older Whirlpools and GEs. The line that goes to a side-by-side, when it comes back from this valve, runs underneath the refrigerator and goes up through the bottom of the door hinge. And the heat of the compressor and condenser sometimes cause these lines to dry out and get brittle and crack. So having some spare line and some John Guest fittings, both 1/4 inch and 5/16 are a good thing to keep on your truck. So if you ever run into one that's leaking, even if it cracked in half, you can cut the half out and reconnect it with a John Guest fitting and get on your way and get it complete. They're inexpensive and highly recommend for truck stop. But let's go back to this ice maker because we need to look at this circuit. So what happens is the first valve goes to the filter and the second valve goes back. When they started putting filters inside the refrigerator, back in the day, they used to be behind the fridge and customers would install it. Oh, I gotta have a filter on there. And you go to their house and that filter's been there 15 years. They never changed it because they never pulled the fridge out to change it. So the manufacturer says, well, let's put a filter inside so a customer can regularly change it, but they made the filter proprietary so that it only fits specific models. And the reason why they had the two separate valves is if you take the filter out of the refrigerator, you wanted to make sure that there was no water pressure there. So they have a water valve before the filter. It would be just like if you're changing the one behind the box and you turn the water off at the house or behind the fridge so you could change the water filter. In this case, by having a filter before and after, a water valve before and after the filter, you don't have to turn the water off. That first valve would keep the pressure from coming out, and that's why when you pull the filter out, it doesn't leak water because they had to do that. Now GE, I know that they put little chips in their filters now, so if a customer buys an aftermarket filter, they might have to go and buy a factory one or figure out how to take the chip out of the one that's in the old ice maker and somehow stick it onto the new one so the board sees that it's a factory water filter. If they don't have a factory water filter, it will not work. So here's the thing. Let's take a look at the voltage that's going to go to this component. So we got the water valve here. I see an issue with this diagram. Damn, I hate it when manufacturers screw up on this diagram. What's the issue with this diagram?
The main valve doesn't have a ground?
It doesn't have a neutral.
Yes.
The manufacturer made a mistake on the diagram. What did I tell you guys? I find these mistakes all the time. I just noticed it myself. There should have been a neutral running here. Like that. You're like, well, what about these two? Well, why are these diodes in the circuit? And I'll explain this in a minute. Why are the diodes in the circuit?
So to prevent backflow of current to those other valves?
Yes.
When you trigger one, so it doesn't work.
When you turn on this one, when you turn on this one, you don't want both of these coming on. You either want the water or the ice. So let's just say, let's do the ice maker one first. So if I energize the ice maker water valve, I'm going to come out pin 3. And I'm going to go here, and this is going to feed the ice maker water valve, and neutral go back out. But I'm also going to go through this diode and go through the main water inlet valve. This other diode is going to prevent the voltage from backfeeding into the dispenser valve so that the water dispenser is not feeding voltage. Now, if we're calling for water on the door, we have to change the circuit. Now we're going to go through pin 5. We're going to feed this valve here. But we're going to go through this diode and go out the main inlet valve like that. This diode is going to prevent the ice maker from calling for water when the customer is calling for voltage. Now both of them can be energized simultaneously though. In other words, you could put your cup for water on the door and the ice maker could be cycling and calling for water at the same time. That could happen. This circuit would not short out or anything. But what could happen if the diodes fail or one of the diodes goes bad? Or let me rephrase that question real quick. And I hope you guys are not in a hurry. I do have some questions and answers about refrigerators on the next slide here, like this. Like questions and answers that I want to go through some of these with you before we go, okay?
Okay.
But let's go back to this. There's two things that can happen if a diode goes bad. One, the diode could open, right? And not allow power to go through anyway. Purpose of the diode is only let electricity flow in one direction. It doesn't let it flow the other. What is the other thing that can happen besides open?
It could go.
Short circuit. Yes, I think Ali, you were saying, as I said, a short circuit. So let's say this diode was shorted. So shorted means it no longer blocks voltage one way. Voltage could go either way. So if the customer is calling for water on the door and energizing these two valves, if this is shorted, what's going to happen? Voltage is also going to go to the ice maker. Now, this is a complaint that I've seen before where this diode shorted, and when the ice maker called for water, the dispenser on the door also energized for a few seconds. So a customer says, yeah, I don't know what every once in a while I walk by the refrigerator and there's a puddle of water on the floor. And you're like, really? Oh, okay. So you open up the door, you pull the grill off, you're looking underneath, you don't see anything leaking water. You put your cup for the water on the door, and all of a sudden it's working fine. But it's the diode for the ice, it's this diode that's shorted, but it still works fine because the other diode is preventing the ice maker. But now when the ice maker is calling for water to send in power here, the power is also backfeeding here. And now the ice maker is supplying voltage to the water on the door as well. And this is a harness that you have to buy. They don't just sell little diodes where you can cut the diode out and put it in the circuit. You have to actually buy the harness that goes underneath the refrigerator. So I wanted to bring it out to your attention. You guys have any questions on that circuitry and how that works? I'll give you a second to think about it. Okay, go ahead.
I have
I had an instance where I had a French door GE that was producing water through the ice maker that was dripping down to the door. Could that have been the same problem that was going on?
No, GE doesn't use these diodes. I think Frigidaire and Electrolux are like the only ones that really use this electrical circuit for that. You might be having the ice maker, either there's too much water pressure or something where the ice maker itself, while it's filling, it's splashing or overflowing, and that's falling into the dispenser in the door. But I guess you'd have to try to cycle the ice maker with the door open and see if you could see where that water's coming from. But it wouldn't be a shorted diode problem like this. This is only in Frigidaire and Electrolux products.
Okay. Thank you.
No problem. So the last part of the schematic that we didn't cover really was the compressor. Now I had these thermistors here just to talk about that, but really I'm not going to talk about this diagram on the left hand side. Why do we show two compressors? One's an STD, so it's got sexually transmitted diseases. Bad joke, I shouldn't put it on the video, but one's an STD and one's a variable speed. What does STD mean?
Regular standard
It's
compressor.
a standard compressor. It means it has a regular relay and overload. And the dotted lines, just like I said before, means that this refrigerator could be built with a standard compressor that has a relay and overload, or it has a VCC compressor. And this isn't the diagram I wanted in this screen, so I will have to come back to it. Look at the standard compressor. It's wired parallel to what? It would be our fan motors. It's not shown in the diagram, but this compressor on most refrigerators, whenever your compressor is running, both your evaporator and condenser fans should be running. When my guys call me for help, I say, yeah, Richard, I got this thing's not cooling. Is the compressor running? Yes. Condenser fan running? Yes. Is the fan in the freezer running? Because these three always run together, whether it's a mechanically controlled refrigerator or electronic controlled refrigerator. We never run the refrigerator without those three components running. So this standard compressor goes off of pin 4. If we don't have a standard compressor, there's no wire attached to that. Now, if we look at the variable speed compressor, what is this, the rectangle representing?
Inverter.
That's the inverter board. So if you look, the inverter board here, line 1 comes in here on pin 3, but just goes right to here. And the light blue, which is neutral, goes right to here. Now this is line 1 to the inverter. The neutral of the inverter is here. Now, when you go to an inverted compressor that has these gray boxes, and I'm going to get a picture while I'm talking to you, if you go there, you're going to see that black and light blue, and that's going to have 120 volts all of the time. Even like in Defrost, there's always voltage at this point. Then you have the control signal. Why don't I see it connected to the board?
It's low voltage. It should be on the other side.
It's low voltage and it should be on the other side. That's why I had this image, but I just realized that I didn't have the right image on it. So when you're looking at these inverters, and I'll just bring this image over here real quick. When you're looking at these inverter boards here, you're going to have two plugs on it. One plug is going to be 120 and one of them is going to be low voltage. Now this is a Frigidaire one, but it's not the same exact diagram. Which one of these two plugs are the ones that are going to give me 120?
Big one?
The bigger one.
Yeah, the bigger one. The higher the voltage, the bigger the wires. This little plug here is going to be low voltage, just so you can just like quickly identify that with the unit. Let me just do this here. So if we go back to the inverter, it says 12 volts DC, but that is your PWM like signal, pulse width modulation. So that 12 volts comes from the main board and tells the inverter board, hey, they want that compressor to run. So if you had a Frigidaire that's not working, you want to check 120 here, and you want to check 12 volts here. Now some of them, there's more testing to be done. You can check what they call frequency and stuff like that, but you want to at least make sure you get the 12 volts. If you have 12 volts, then most likely either the inverter or your compressor is your problem. Now I want to go back to that first diagram because I wanted to show you here, right here is that 12 volt circuit. This pin 1, pin 2 was the plug on the compressor there. I think I can move it down some so I could show you both at the same time. Let me make it just a little bit smaller to fit on the screen. Move this fridge over. So these two wires here, the control signal is this right here. This red and black and white. And red is usually positive and black is usually negative. So on low voltage components on appliances, if they have a red and a black, just like a car battery, red is positive, black is negative when you're doing your test. But this is the low voltage going to the compressor, and yes, you can check pin 11 and 12 on J4 to see if you have the 12 volts. If you have 12 volts here and 120 volts at this plug, then your problem is either your compressor or inverter. Now the only thing else you could do is you could ohm out the compressor, and on an inverted compressor with the 3 pins, you'll have three windings in a delta formation, which is just basically a triangle, and they all 3 read the same resistance, like 8, 20 ohms, whatever, but all 3 of them should have the same identical resistance. If that happens, you have good resistance and you have the 12 volts and 120 volts going to the inverter. It is possible your inverter's bad. Now if you got good rapport with your parts house, if I went to this job and I had to come back with a compressor, an inverter, I'd attempt to install the inverter first and see if the compressor on the customer's fridge is running. And then if I don't open the compressor box, hopefully I can just return it to the parts house and say, oh, the customer canceled on me, and get my money back for the compressor if I don't need it. But if I change the inverter and it still don't work, I'm going to change the compressor too and tell the customer, listen, we got to change both of these. Your compressor's bad. This is all part of one assembly, and I'll get my money for my parts. I wouldn't want to rob the customer, but I mean, you've already installed this inverter on this unit. You either got to keep it for truck stock now or sell it to the customer. And it wouldn't be a bad idea here. It's just like changing a standard compressor. It's always good to change the relay and overload on a standard compressor, not just change the compressor and use the old electricals. So that is the variable compressor on there. Does anybody have any questions on anything on this refrigerator diagram we covered before I go over the questions on the refrigerator?
Yeah, I have a question. It's not specifically on the Frigidaire, but GE side-by-side. Matter of fact, I have the model number.
Okay.
So, like, how you were saying that most people wire their compressor such that if the compressor is running, the condenser fan should be running?
Yes, do you want to give me the model number?
Yeah, the model number is G as in George, S as in Sam, E as in Erica, 25, H as in Harry, S as in Sam, H as in Harry, B as in boy, H as in Harry, S as in Sam, S as in Sam.
Jeez, a lot of HSBS's.
Yeah.
Okay, hold on a second. I'm on Appliantology. My good boy Samurai here had a service manual for it, so I'm just downloading it. Give me a second here to open it up, and we'll take a look at the schematic. Okay, so here is the refrigerator you were just talking about.
Mm-hmm.
And let's go to here, and we're looking at the compressor and the condenser fan. Now if you look here, this one, and I'll zoom in on it even more, it looks like a J8 off the board, which is feeding the relay and overload of your compressor. But if you also see, this one wire is also feeding what? My condenser fan motor. So what exactly was your question?
So I found that it's initially I thought it was a seal system problem, because they were reporting not freezing properly, things not freezing properly, and when I opened the evaporator, I saw that the evaporator is kind of like maybe half frosted, half lightly frosted. But then I accidentally found out that at some point the evaporator fan kept running, but the compressor and the condenser were off.
Okay, I think that was like WR55X1008 or something like that. That board in the back of the refrigerator.
Yeah,
that's garbage.
Yeah.
They had so many problems. You'd tap on the board and the compressor would come back on.
Yeah. So I jumped the compressor, and the compressor started running. So
yeah, GE had problems with those older boards that go on the back of the refrigerator. And sometimes if you tap it, it'll run, or tap it and it'll stop running. And it's usually that main board is the problem.
Well, guess what? So I replaced the board.
Okay.
And so the day I replaced the board, because I also have experience with that board, whereby when you unplug it, plug it back in, the board dies. So I was hoping that it doesn't happen when I install the new board, but so I installed a new board, so the compressor wouldn't run. So I thought, okay, maybe it's a delay, and then it started running, right? So it started running. I can hear the evaporator. So I removed the evaporator cover. I waited until the frost started coming back up. So the frost came up to like 2/3 of the evaporator. So I said, okay, I think I'm good now. So I started trying to put back the cover of at the back, and then the compressor stopped.
Well, that's I couldn't tell you what that is. I guess the first thing you want to see is the compressor and condenser fans stop.
Yeah, both of them stopped.
Well, here's the thing could have happened. You were putting the cover on when it stopped, and if one of those plugs or connectors might have been slightly loose, and you like disconnected and connected it back again for a second, the board might go into like a time delay where it stopped it because the connector wasn't good, so it lost voltage and the compressor stopped and the voltage came back on. It might have said, hey, the power was off and on for a second, and then went into a time delay. I don't know. I guess the first thing you'd want to do is check voltage to the board. So you'd want to go to this J8 and see if power's coming out, and somehow find an orange right on the board here, which is this bottom pin here for your neutral, and see if you got voltage coming off the board when the compressor's not running. At that point, you can determine whether the problem's at your board or at the compressor. But did the evaporator fan stop when that compressor stopped?
No, the evaporator fan kept running.
Well, it has to be an electrical connector problem. If the condenser fan and compressor shut off, remember, they both get power from the same relay on the board. So you need to determine whether the board is continuing to send power out or not.
Is there a way to put it in diagnostic mode and force the compressor to run?
I don't think this refrigerator really has a diagnostic.
Yeah, it doesn't have diagnostic.
It says display board.
Yeah, but this is one of those older refrigerators that had the, I forgot the part number for that board, 10043 or something like that. GE's had this one board that is crazy. Now the other thing also I've seen with GE refrigerators, but usually on the monograms, is GE had a problem at one point with their thermistors failing. And from my understanding, the thermistors on a GE refrigerator all use the same part number no matter which thermistor it is. So I'd carry 2 or 3 of them on my truck all the time because they fail a lot. I'm not saying that is what your problem is. I would have to actually see the refrigerator at this point, and I would also have to know if this pin here and the neutral pin here, did you have 120 when your compressor wasn't running? That is, the worst part about it is when you go there and you determine, hey, this is my fault, and then you change the part and it's not working again. I always tell everybody, listen, if you diagnosed it and you said it was a bad board, now you change the board and it's not working again, don't get caught up and say, well, it's a new board, it can't be the board. Go back and start over like it's your first time troubleshooting that refrige, and then troubleshoot and say, is the board sending power? You know what I mean? Don't get caught up and say, well, I know it's not the board, I just put a brand new board in there. Yeah, well, what if that board got thrown around in a truck and something happened to that board? They could have a loose or bad connection on the board.
Yeah, and I was thinking, well, it couldn't be on Defrost because the evaporator fan was running.
Yes.
Yeah, so it was definitely a head scratcher for me.
And it might have just been an electrical connection loose, and as you're putting the cover on, you push to get it, and the connection cut the power off and cut it back on, and the time delay is just going to shut off the compressor, not the fans. Okay? But that's about the most answer I could give you without being at the unit and testing it out myself. So I got some refrigerator questions for you guys. Alright? How many days can a refrigerator go without defrosting before a customer starts complaining of cooling and losing food?
Is it 3 days?
Doesn't it depend on the opening and closing of the refrigerator?
Well, yeah, it does. It is an average, though.
What type of timer is it?
It's a
7 days.
It's about 5 to 7 days is a good answer. It's a mechanical timer, just a regular unit. I think this is a GE no, that's not a GE vat. Might be a Whirlpool. I think that evaporator motor clip is a Whirlpool. But it's an average of 5 to 7 days. The reason why I bring that up is if you go to someone's house and it's a defrost problem and you have to order parts, if you manually defrost this evaporator so we get airflow and cooling again, a customer can use the refrigerator for at least a week before you come back and replace that part. So at least you say, ma'am, listen, I got it where it's working, but it's not completely fixed till I come back with the part. This is going to happen again. Don't pack your refrigerator full of food. Just buy what you need till I come back, and your refrigerator should work just fine. So about 5 to 7 days is the average amount of time where this ice will build up, and then we won't get any airflow through the coils, and then we'll lose cooling. Question number 2. A continuous run, is supposed to say timer, will defrost how many times a day? Now we have 2 different runs here, so let's look at the one on the left. Look at this timer here.
Can you zoom it out, please, Richard?
Sure, give me 1 second to change my...
Every 8 hours?
It'll defrost every 8 hours on a continuous run cycle. And this one would be how long?
6 hours.
Okay, so the 8 hour would be 3 times a day, 6 hours would be 4 times a day. Okay? So that's, I just wanted you guys just to be able to why I grabbed the question by mistake here. Let's get these timers out of the way. On average, how many hours a defrost cycle start? On average, how many hours does a defrost start to happen? It would be 8 hours or 6 hours depending on the timer. So that we answered that one. Let's go to the next question. To test the timer contact for defrost, what pins would you check on the timer?
Repeat the question.
What pins on the timer would you check the timer contact for defrost?
2 and 3.
Not 2 and 3. Here's our timer here. Here's our defrost heater here. Right there is where you test pin 1 and 2. That's your defrost. And this goes for 99% of these mechanical timers. 1 and 2 is defrost, and 1 and 4 is cooling. If we look at this timer here, 1 is usually power in, and 2 and 4 are the power out. 2 is usually defrost, 4 is usually cooling. There are some instances that it's not, but that's usually how most refrigerators are wired. What is pin 3?
It's neutral.
It's neutral for the timer motor, as you can see there.
Richard, why can't I just check the voltage on between 3 and 2?
Yes, you could check voltage between 3 and 2. I was just saying what pins would you check just to check the contact. 1 and 2 would be ohms, 2 and 3 would be voltage, but that is also a way you could do it. If you had voltage there, that's telling you that the voltage is coming in through 1 and going out through 2, and the switch is good, because if I have no voltage, my timer's bad. Okay?
Mm-hmm.
The defrost timer is what? And I don't know why I kept putting 2 pictures on here. Now this is something I created a long time ago. So let's take a look at the one on the left. What's the closest answer?
8 hours and 22 minutes.
Okay, so it's 8 hours and 22 minutes would be the correct answer for that one. Okay, so 8 hours is how long it takes to go in between cycles, like the next time it's going to defrost, and the 22 minutes is how long the timer is going to stay in defrost before it goes back into cooling. Does that mean the defrost heater is on for 22 minutes?
No.
So what?
It's regulated by the thermostat.
Yeah, by the defrost thermostat or thermistor, if it's a control board. Yeah, but yeah, that's so we will stay in defrost for 22 minutes, but it doesn't mean that we're defrosting for a full 22 minutes, or at least the heater's not on. How many components are in the defrost cycle?
How many what?
Components make up a defrost cycle.
2.
Well, I have them there on the left. There's 3.
No,
We have a timer, defrost thermostat, and a defrost heater. It's funny, this diagram is a Whirlpool diagram, but that's a GE defrost heater. What part makes up a defrost cycle? What parts are they? They are the defrost heater, defrost timer, and defrost thermostat. Alright? Simple? Let's see if we got any more questions here. You notice the refrigerator does not seem to defrost. A test is made between brown and white. So let's find those 2 terminals here. Brown is here and white is neutral. So you're making a test between brown and white, which shows 0 volts at this point. A second test had a reading of 120 volts between pink and white. So from here to here, we had 120 volts. What part is most likely failed?
Environmental.
The defrost thermostat. You had 120 volts here. That means the timer contact closed and voltage is coming out, but I didn't have it here, so that means the bimetal is not allowing the voltage to pass through. You guys got that? You got questions, say, hey, I don't get it. I don't know what the heck you talking about. But Whirlpool has a plug up in the control panel area. Now, not all the newer ones have it, but the older refrigerators have it. And it's a plug that has a pink and a brown wire, and it's just hanging there. It's not even there's nothing that plugs into it, and I have a lot of students that would work on that refrigerator say, "Hey, Richard, I got a plug here, but it doesn't connect to anything." It's a test terminal that I could ohm out the defrost thermostat from pink to brown. If I put my meter inside there, I can ohm it out. I could check voltage going off the timer. I could check voltage coming off the bimetal, or I could even put a test wire here to bypass the defrost thermostat so I can melt the ice on the evaporator. If I go to someone's house, and let's just say I go to someone's house, this refrigerator, and I see it's not defrosting, the evaporator's covered in ice, and I determine the defrost thermostat's open. If I jump out this plug here, I put a wire here and put the timer in defrost, I go out to my truck to get a new defrost thermostat, but I bypass the defrost thermostat so that the heater will start melting the ice. So I don't have to sit there too long and manually defrost it. If the timer times out and I still got a lot of ice, I'm going to go back and put it back on and defrost. And just get that defrost heater to keep melting that ice. Yes, sir.
Yeah, so I also see that pink and brown wire on the other ADC timer.
Yes.
Yeah, is that the same principle?
On Whirlpools, yes. That's what pink and brown are.
Timer?
That's what that is. That's to test the bimetal, test the heater from brown to white, test the bimetal pink to brown. And also, pink to white can tell you if the board is sending the voltage out. If you go into the defrost and you notice your heater's not working, that you could check output voltage there. Okay? Any other questions before I go to the next screen? On defrost systems, where the timer clock motor is energized through the thermostat. The timer runs when the thermostat is closed. The timer runs when the thermostat is open. The timer runs continuously except in the defrost cycle. Hey Robert, you joined. The class started at 12 Eastern. We're getting close to ending, but welcome to the class. I did record this, by the way. So let's go back to the question. On defrost systems where the timer motor is energized through the thermostat, does the timer run all the time? Does the timer run only when the thermostat is open, or does the timer run when the thermostat is closed?
It should
When it's open?
When it's closed. Watch the circuit here. When power comes in, and this is weird because a lot of people aren't familiar with this. I go through here, when that thermostat is closed, I go through the timer motor. The defrost thermostat and heater have to be good in order for the timer motor to advance on that unit. That timer motor is in series with the defrost heater. You see that? Now when I go into defrost, and this switch goes here to defrost, power bypasses that timer motor and goes through the heater, but I need that timer motor to run. So how is that timer motor getting power? It's getting power through the compressor. The compressor is only like 3 or 4 ohms. The defrost heater is like 20 or 30. But the timer motor's in series with those components. This one timer is different than all the other timers in the refrigerator. And it's wired different. I went to a customer's house, and the customer stated the refrigerator wasn't cooling. And I thought it was a defrost problem. I advanced the timer into defrost, and it was heating. So my determination was the timer wasn't advancing and going into the defrost cycle. So I went out to my truck and put another timer in there. Lady called me back a week later, says it's not defrosting. And what happened on the standard timer Let's take a look at this for a second. Do you guys remember the numbers on this timer here? 1 is power in, 3 is neutral, 4 is cooling, 2 is defrost. Right? So let's put those numbers to this one. This is 1 because it's going to the pole of the switch. If you look here, that's the pole of the switch right there. So that's pin 1. Neutral on the motor is pin what? 3, right? So that's 3. Let me I can't draw, guys. Not with this mouse. So this is pin 3, and pin 2 is defrost, right? And pin 4 is cooling, right? So 1 and 3 is neutral and line 1. And 1 and 3 is neutral and line 1. But look at how power goes right through the timer and out. This is what we call continuous run. That means this timer is always running. Always running. You turn the thermostat off. Say, I'm going to put the fridge in the garage. It's plugged in, but I'm just going to turn the thermostat off because I don't want the refrigerator to run. Guess what? Your timer's still running. Even if you don't use that refrigerator for years, that timer's always running in this circuit. But this one here, if the thermostat opens, the timer stops. And the location of the pins have changed a little bit because the timer motor on this one is connected to pin 1 and 3. What's the pins that the timer is connected to on this one? Come on, guys. I want what 2 pins is the timer motor connected to on this timer?
1 and 3?
It's 2 and 3. Now I got this video. I don't want to play the video for you. I want to show you something inside this timer. If you look here, this is pin 1 power coming in, pin 2 defrost coming out. Well, let me just copy. You know what? Let me take a screenshot and bring it into my thing. I want to do something. Wait a minute. I just said new. Let me get this out of my screen here. Okay, here. I'll get this timer. I want to show you something that I did because this timer internally is wired different from all the other timers. If you take a regular timer and put on this refrigerator, the customer's going to call you out and tell you it is not defrosting. So if we go back to this here, and I'll bring this image in here, power comes in here. So this is pin 1 here. This is pin 2 for defrost. This is pin 4 for cooling, and the timer motor's here. And what happened is normally power goes in pin 1 and through a piece of metal connected to the timer motor here where a capacitor is in the motor goes out here. But in this case the timer motor is connected to pin 2 and 3. So there if you get an old timer, I want you guys to open up the timer, and on that timer there was a piece of metal that connects here and connects to these pins right on top, and I was able to move the pin from the top of this one and move it to the top of this one, and now I made it like the original factory timer. So next time you get a timer that you've replaced on a refrigerator or an old timer, open it up and see how your timer is wired. That timer motor should have a connection right to pin 1. But on this Whirlpool model only, it has to go to pin 2. And I was able just to move it and make it work because I didn't have that timer, and I didn't want to have to go and order the timer that's wired that way and then go back to a customer's house another day. I wanted that complete that day and get paid for that job. So that's what that is. So any questions on that? No? Okay. So let's go to this one. When putting the defrost timer in a defrost cycle, the contacts that are closed are And we said that 1 and 2. 1 and 2 sends power to our defrost. And if we look here, it is also 1 and 2 going to defrost. This is a Maytag on the right, Whirlpool on the left. When putting the defrost timer in a cooling cycle, the contacts that are closed are 1 and 4 and 1 and 4. The only thing different on that other Whirlpool diagram is the way the timer motor is wired internally. And I'm not going to go the 4 ways to use the test terminal. I gave you a few ways to check the bimetal, bypass, check voltage off the timer. You can ohm out the defrost heater. Those were the things on that one question. Which terminal on a Maytag refrigerator would you use to check the defrost heater for continuity? Looking at this diagram, which 2 pins on the timer this diagram, 2 and 3. Here and here, 2 and 3. That goes through neutral and back through here. Now I think I briefly talked about this last week, and I talked about this defrost thermostat. If you guys don't remember or weren't here, let me just show you. This defrost thermostat says for diagnostic continuity check, 240,000 ohms. There's 2 parts to this defrost thermostat. It has a switch and it has a resistor. Maytag is the only one that does this. If this thermostat is closed and you put, let me get my meter leads here. Oh, it's in the other screen, I'm sorry. Go here and get my meter leads for the test. Get this one and this one. So now you want to check the heater. We got a meter lead here and we got a meter lead here. If the heater and defrost thermostat's good, what is the approximate resistance I would get across the defrost heater?
240K?
No. 30 ohms. The heater itself is 30 ohms. If the defrost thermostat is closed here, that resistance across the thermostat would say 0 ohms. It's just a closed switch. So testing, I test through the bimetal and through the heater, I get 30 ohms. But if my bimetal or defrost thermostat is open, the top half is open, then if I do this same test, I'll go through the heater and through the resistor on the bottom and come back around. So now I'll get that 240,000 ohms, but that's telling me that my defrost thermostat is open and my heater is good. If I get an infinity reading, an open circuit, what most likely is bad there? The heating element. Now, could I put a regular defrost thermostat on this?
No.
I could, the refrigerator would work. I would just lose that 240,000 ohm test point. In other words, I couldn't. All that resistor is just to let you know, hey, the bimetal's open, but the circuit's good. That's it. So you don't have to go back to the heater and to the bimetal to determine which one of those are bad. Then if you have it on the truck, you're going to do it. But this Maytag one has a specific defrost thermostat different from all the others. And that's just for testing to see if that thermostat's good or bad. And you know what? While I'm here, like, look here. Remember I told you about that Whirlpool and the motors connected between 1 and 3? Look here where it shows motors pin 1 and 3. And if you could open this timer up and move this over to 2, it would work on those Whirlpool ones that I was telling you about. So that's what I was talking about.
Do the new refrigerators have those timers as well, like the new ones?
Most of
making them with those timers?
Most of them don't use timers at all. The timers are going away because manufacturers are being required to be as energy efficient as possible, and having electronic controlled defrost allows you to shorten defrost time, maybe not defrost as many times a day, and it gives you a little bit more accuracy on when and how you need to defrost. And if we can defrost less, we're going to save money by not defrosting.
So they're putting them into control boards now?
Well, the control board itself is either it's a separate defrost control board, or the defrost is built into the main circuit board. Like on this refrigerator here, if we look at, I'll go to where it is on the diagram. Let me get to the main diagram here. If we look at this diagram here, yeah, I know it's a little hard to read. If I zoom in, it's probably going to be blurry, but we got our freezer evaporator here. This is our defrost heater right here, and our thermal cutout, which is our defrost thermostat, and it's coming right off the main board. So there is no separate board or no defrost timer in the computer controlled unit.
Gotcha.
Okay.
So if it was damaged, like the control board was damaged from that section on the control board, can you repair it? Can it be repaired directly from the control board?
A lot of boards can't be repaired, but here's a couple of things. One, unless you physically see what's bad, you don't know if it's a resistor or part of the circuit or whatever. And think about this. If the board failed and you attempt to repair the board, let's say it takes you 30 minutes to take the board out, determine what's wrong, solder, repair, change a relay if you even had it, and then put it back in, how long can you guarantee that board for?
Right.
You know, and so you're going to lose money. You're better off putting a board in with a warranty, and if it fails, guess what? You go back to the parts house and they give you another one under warranty, and you can get that same warranty of 90 days or 1 year, depending on the manufacturer, to the customer. So it's a lot easier to swap a board out than it is to fix it and find out that there's other things wrong with that board. Once you fix that, there's another problem. So it really isn't worth all that time to try to fix that.
Okay. Well, I ask because I sell appliances,
Uh-huh.
but I'm starting now with the refrigerators. I kind of, put that to the side. I've been trying to learn the refrigeration part of it and all that. And I was just wondering if it would be better off for me, just like rather than like having to go buy a whole, because it wouldn't be worth buying a control board, but like to repair it, And of course I need to learn a little bit of the schematics to get to that point. You know what I mean?
Yes.
So I was just wondering on that. Probably be better off trying to learning how to fix the control board, but I don't know.
Yeah. Well, on our site real quick, and I didn't try to go into a commercial here, but for our paid members, we have this TMM self-study, but obviously I'm not even logged in, so I gotta, oops, I should have said log in, my mistake. Give me a second here to log in. I don't know why it does it twice, but when you log in, under self-study, right now I've only got this, and I'm working on the diagram one, so that's why I'm doing so many lectures and videos, because I'm going to embed some of these into the class. I have these chapters that go over the refrigeration system, where you can read and learn about different evaporators. I go as far as like chapter 5, I'm talking about pressure readings and like high pressure, low pressure, like if you got a restriction, what to look for. And in the other chapters I go over some of the tools. I talk about the compressors. This here is right now online for all of our paid members. I break down the compressor, and then I embed some of these videos are on there, but these are all videos and lectures where I talk about the linear compressors and the other compressors. So this is all part of the paid member section. And like I said at the beginning, you came in a little later, I work 3 jobs. So for me to write this and create the images and add videos, and it takes forever. I wish I had a team of people, but TMM, Brandon and I don't make a lot of money. We're lucky if we make about $4,000 or $5,000 a piece for the whole year for TMM. A lot of this.
Yeah, I've watched probably all your videos on YouTube there. So I was like, man, I want to see what these guys are about and watch the class. But I love the videos you guys have on YouTube. I mean, it's definitely helped me big time.
Thanks. I apologize, but I was adamant about putting commercials on the videos, but I'm not getting enough members in this paid member section here to support our school, the warehouse, the electricity, and all the effort and time we put together with these Saturday classes. Every other Saturday, our paid members get a class, and I vary the material that we talk about. But this stuff here is what I'm trying to do is just to create a complete, all-inclusive. This whole thing. Eventually, I'm going to have one on washers, dryers, electricity, and everything else, where someone could go through a chapter, and each chapter has questions you can download and answer, and then it has a link to a site where you can actually take chapter tests. So
how much is it like to get like a full package? Like how does it work?
We pay
really
$25 a month, and it is reoccurring, but there's cancel at any time. There's no commitment, or it's a little bit cheaper. It's like $200 something for the whole year. And that allows you to be part of these Saturday classes. We have a Voxer app, which you guys can be part of Voxer, where you can ask questions and get help. I don't want to get too long into it, but Robert, if you want, I'll give you my number, and I'll text it to you after the class, so I'm not recording it. And then if you want to call, I'll be more than happy to answer all of your questions, okay?
Yep, that sounds good. Thank you.
So so that defrost thermostat we've already gone over. If you test a defrost heater with 240,000 ohms, we said that'd be an open thermostat. So this timer, is it called a continuous run or cumulative run timer?
That's cumulative.
Cumulative, yes, because every time the thermostat opens, the timer stops advancing. So if it's an 8-hour timer on a continuous run, which is like this circuit here, this is a continuous run timer. Power comes in, this is a capacitor here, it goes right to neutral. Well, no, this is cumulative run because the thermostat controls it. If the thermostat opens, the timer stops running. So this one here is a continuous run. This one here, where the timer's connected to power all the time. Cumulative run was it's not a different timer. It's the way they wire the power to the timer, whether the thermostat in the refrigerator controls the motor or not. You can put the same 6-8 hour timer there, but it's only 8 hours when the temperature control is closed. So temperature control for 30 minutes and then opens for 20, the timer only accumulated 30 minutes of time. It still needs 7 hours and 30 minutes before it goes into defrost. So it's called cumulative run, which means whenever the compressor's running, then the timer's running. That's basically how you have to look at it. So if we go here, in the Maytag refrigerator, Maytag diagram ice maker on top. So this one here, I already gave the answer. This is cumulative run. You see where power comes in, line 1 goes through the thermostat, and then the timer motor, and when the thermostat opens, the compressor stops, but the timer stops advancing until we call for cooling again. So that's what cumulative run means. It's not a different timer, it's the way the timer's wired in the circuit. And a lot of manufacturers now, if they're still using a mechanical timer like these, they're most likely going to be a cumulative run. The older ones are going to be the continuous run. Okay, I think we already did that one. Some of these are duplicates. So that's the ends of the questions. If anybody else got any other questions, feel free to ask them now before class is over.
I have a question, Richard.
Yes.
Do you guys mind sharing the stock that you have in your trucks? Because I was trying to buy those parts on my own. I wrote a little program that goes against local appliance store, scraping all the pages and getting all the parts and selecting and sorting them by most sellable items. But at the end, I learned that their website is not updated all the time.
Yeah, I'm sorry, I was typing when you were talking. It's say the question again.
Sorry. Yeah, I was trying to create an inventory of parts that.
The truck stock. That's what I was thinking. Now, listen, truck stock. I have one guy that's really, really good, making all kinds of money fixing appliances. But I I asked other technicians to see what he had on his truck stock so they can make their truck stock. But it turned out that, like, down in Florida, we got a city called Hialeah. It's mainly middle class, blue collar people. And they lived, let's say before this recession, they lived in $100,000 homes. So they weren't cheap homes, but they weren't super expensive. Now we got a place called Weston, and maybe 15-minute drive from Hialeah, that the cheapest house is $1 million house. Now it's probably like 2 or 3 million. You know, this is where the Miami Dolphins and the Miami Heat basketball players are living. So the truck stock that the guy in Hialeah carries is going to be different product than the person that services the Weston area. Now, if you want to build up truck stock, get with your parts distributor, Marcone or Encompass, and you can say, hey, can you give me a list of fast-moving parts for Whirlpool, Frigidaire, and GE? And what they'll do is they'll give you a list of parts and the volume that they sold within 1 year, that you could look and say, oh, they sold 40 of these in 1 year and only 2 of these in 1 year, and then I've seen this. I tell people a truck stock has to be dependent on you, the individual, and the area you service, because you and I could work for the same company, but I might see a lot of Daycor and Sub-Zeros and Milas, and you may work on simple Whirlpools and GEs, so the parts I'm going to carry are going to be different. So I have 23 trucks, and I started doing inventory on them, and I gave up. I just gave up because guys were carrying parts they would never use, and other guys, some of them could use them, but it all depends on the area you service.
I see. Okay.
Okay. Any other questions?